All right, this is going to be problem 1 through 5 on page 154. The background knowledge that you need to know about it says in the 19th century, many adventurers traveled to North America to search for gold. A man named Dan Jackson owned some land where gold had been found. Instead of digging for the gold himself, he rented plots of land to the adventurers. The rent was to give Dan 50% of the gold found on the plot of land. Dan gave each adventurer 4 stakes and a rope that was exactly 100 meters long. Each adventurer had to use the stakes and rope to mark off a rectangle with north to south and east to west sides. So question number 1 was, did everyone get the same area to dig for gold? Explain your answer. Even though the adventurers had the same opportunity to have the same area, it depended on what dimensions they picked for their plot of land. So you can see in my example, no, not everyone had the same area, because if an adventurer used the dimensions of 25 by 25, their area of land would be 625, because area is length times width. However, if an adventurer used the dimensions of a 20 by 30 plot, their land would only be 600 meters squared. So even though they had the potential, not all of the land area was the same. Number 2, I kind of combined these in this presentation. So on number 2, you were supposed to, on a graph paper, draw at least 5 different rectangles that had the perimeters of 100 meters. And then you were supposed to, on part B, cut them out and lay them so that each of their corners were down there, met at the bottom left. So you can see here is one potential area plot that they could have had. Here's another, and then there's my 4th, and my last one is my 5th one. So number 3, it says you should notice that all the upper right vertices of your rectangle seem to lie on a line. What is the equation of that line? Use x and y as the dimensions of the rectangles. So you can see here that this is the line that they make on the corners. And so this was my final answer of y equals negative x plus 50. But what I did to find that is I picked 2 points on the line. So let's say this one right here, which would be 20, 30. And then let's say this one down here, which would be 40, 10. So then we use the slope formula, which is y2 minus y1 over x2 minus x1. My y2 is going to be 10 minus my y1 is 30 all over x2, which is 40, minus x1, which is 20. When I subtract, I get negative 20 on top, and I get 20 on bottom. You can reduce this to make it a negative 1. So your slope is negative 1. If we use our equation y equals mx plus b, we know that this is slope, so I'm going to substitute negative 1 in for slope. And then our b is our y-intercept, and our y-intercept is wherever x is 0, what is y? So if we go up here to our line, x is 0, y is 50. So negative 1x plus 50, and that equals y. So that is where I got the equation for the line. Question number 4 told us to calculate the area of each rectangle and organize all of your information in the table. So I had rectangles with a length of 5 and then a width of 45, so the area would have been 225 meters squared, because to find the area of a rectangle, it's length times width. And then I had 20 times 30, which would give me 600. 25 times 25 gave me 625. 35 by 15 gave me 525. And then 40 by 10 gave me 400 meters squared. So again, you can see that depending on the dimensions that the adventurers chose for their rectangles, depended on how much area they had of land. Number 5 says, what was the secret? Oh, so the last part of number 4, said one of the diggers discovered that one kind of rectangle always had the greatest area. He decided to sell the secret to the other diggers. So what was the secret? A perfect square, which means when the length and the width are the same, the area is going to be the greatest.